ended with starting our CellProfiler pipeline. So now, once it was finished, we can look into our output folder, and what we will find are three independent text files, as we have defined here for the cells, for the cytoplasm, and for the nuclei containing the respective measurements. We also find this one image that we defined here, which is sort of the overlay image, and the overlaid again with the outline we defined before, just as a confirmation that our pipeline was working as we expected. Okay, so now the point of this video is to show you how to extract the information from these text files, such as, for example, the nuclear signal per cell, define a threshold, and count the number of infected cells that are above that particular threshold. So now you can do this, of course, with something like Excel, but these are quite large text files, and I would advise not to use, or I would advise to use a programming language, or do this programmatically, via any form of scripting, as this will make your life a lot easier. So I've done this before in MATLAB, but I want to show you a different way. So I wrote a little Python script to do this. So to run Python scripts and to develop them, you need some kind of Python environment, and an easy way to get one is to use this Anaconda distribution. So there's a big one and a small one. So I think I just installed it and I used the big one. So the normal one, there's also a mini conda, which I think can also give you most of the features, but any of those you will need to run this example script. So just go to Google Anaconda and Windows, and you will get here, and you download your installer and go through the installation procedure. So Anaconda on Windows comes with its own command prompt. On Mac, I simply use the terminal, which is here. So this is the terminal environment. So what we do in the beginning is to navigate to the folder where we have saved this Python notebook, IPython notebook that I shared with you. So in my case, it's in this folder here. So we go there, and then we start one of the sort of scripting environments that comes with Anaconda, and it's called Jupyter Notebook. You'll see what it is in a moment. So we can start the Jupyter Notebook. It's very convenient. It starts up in the browser. Oh, it also went into the wrong window here. So here, this is how it starts, and it starts in the folder that you just selected. And so we find out the IPython notebook that I shared with you, which is this CellProfiler Visu notebook. Click on it. It opens a new tab, and this is you see this sort of Jupyter environment. So it's quite clean, and basically what it does, it basically shows you a command prompt type of organization. So you have these sort of cells which contain commands, and you can run these commands one after the other, and it will give you an output if there is one, or show you a plot if there is one, and so on. So it's quite a convenient way to develop these Python scripts. There's other ways too, but we'll not go into that. Okay, so first of all, we need to import certain packages, which is quite standard for Python. So we do that. The second part is to import the data. So I added a couple of annotations in here that I hope are useful. So we direct it to this output folder where we have our, let's say, nuclei text file. We import this text file. I usually, because you don't have a visual, or you don't have this kind of workspace as you have it, for example, in MATLAB, I always find it useful to ask basically Python, or ask your Jupyter Notebook, what did you actually import? So it shows me the shape of that data frame that was just imported. So it's 36,000 lines and 29 columns. So that's sort of, I think, what I would expect. You can also use this data.describe command, and it shows you the different columns, just to check if the data was basically imported in the right way. and it shows you a couple of statistics which are not useful for the metadata columns. They may be useful for the intensity columns. But this is for me just to see that the data was imported in the right way. Okay, so now what we want to do is we want to extract the respective cell lines, and we want to extract the respective conditions as we have them defined in our metadata. So if we still remember it, we can skip these two or these three cells, but if we don't remember how we called our cells and our conditions, we can use these commands here to identify sort of the unique elements, which is basically looking into that respective column, which is the column metadata cell type, and check what values do we have in there. So we have two values, one is A549, one is MGLU. Actually, this one we can skip because I had it before. Okay, so now we do the same thing for the condition. We can check the conditions, which in this case will be for both cell lines. We have the 6 hours, 8 hours, and a negative. This one I did twice, so I call it 6 hours new, but this will be anyway something else in your particular case. So then we have to extract and put into variables the respective cell type and condition combinations. So with these commands here, we select a certain string in that cell type, let's say A549, and we combine it with this Boolean operator with a metadata condition such as negative or 8 hours or 6 hours. We put them into variables like these ones here. And we can again at the end check if it extracted something useful, which in this case, since we don't know how many there are, it extracted 5,000 lines and all the 29 columns, which makes sense. So then usually I just plot the DNA, and as we have seen it before in the CellProfiler scatter plot, I plot the DNA intensity against the nucleoprotein intensity to see if our analysis basically would make sense, or to control if our extraction was useful. So this is the control plot. No, there's no legend so far, but in black you can see the control, so the negative control, which is uninfected, and in red you see all of the infected cells. You can already tell, you don't see it, but you can already tell that there's a difference between black and red, and that's what we want to extract in the next cell. We can do the same thing also for the second cell line. So if you have only cell line, obviously you can just remove all of the stuff that is concerned with the second cell line, and so on. So this is just really to show you the basic steps, and you can, of course, copy that particular notebook and modify it in a way you find it useful. Okay. So then in this case, where we just want to set a threshold and we want to count the number of cells that are above a certain threshold, I define this threshold here. And in this case, to make it, to prevent any form of guessing, I just say that the threshold could be the mean intensity of the nucleoprotein, which will be somewhere here, plus 1 standard deviation. So I do that for both of the negative control samples, conditions. And it gives us the value. Again, this printout is really only to check if it extracted something useful. This is really always only for me to control if I'm doing something that is meaningful. Okay. So now we can count the number of cells that are above that threshold. Again, this is what is done here. So with this length option or command, we ask it to give out the number of cells within the NP density column that are above a threshold. And since we want to know the fraction, we divide it by the total length of that data frame. So we do that for the negative control and for all the other conditions. This is really always the same thing, just copy and paste. And at the end, what we want is either to show us some sort of visual representation and something to print out and to copy into maybe another program where we want to save this, or where we want to make a plot or anything else. So if we have more experiments like this, maybe something to do is to copy the extracted values into a GraphPad file or an Excel file or anything else to keep track and make other statistical measurements and so on. So if we run this cell, it gives us an error because the threshold is not defined. Yes. And I also just noticed something else, that I renamed the threshold. Up, up. Right. Okay. There we go. Name samples is not defined in 36. Oh yes, here. Guess I changed a couple of things after. Okay, here we go. So what we get is are these two bar plots. Again, that needs to be adapted for your respective analysis. This is really just to show you one example of how to do this. It gives us a visual representation of what we expect, and it prints out the extracted values that are plotted here so that we can use them for any other purposes.